In this lecture, we start by talking about subsets. Now, a set A is said to be a subset of set B if every element of set A is also an element of set B. So you write it as A subset of B. So this is a symbol of subset. Now, first example is that null set is a subset of every set. So this null set belongs to every set because it is just an empty set. So nothing is a part of everything. Now another example. So this 1, 2 is a subset of 1, 2, 3. In the previous lecture, we showed how natural numbers form a subset of integers, integers form a subset of rational numbers, and rational number form subsets of real numbers. Now we talk about subsets of the real line. So intervals are subsets of real line. So there are 4 kinds of interval we will talk about. So first is open interval. So open interval are of the form say as 3, 5. So say this is the real line. Then the open interval is, you write like this. You make a hole A and then you have B right here. So this is the open interval. So this is nothing but the real line. So let us recall what a real line is. So real line is like this. You have 0 here, then you have numbers 1 here, 2 here, 3 here, and it keeps going on. And you have -1 here, -2 here, and it keeps going on this way also. And then you have numbers like √2 which are lying somewhere right here. And then you have √5, √7, and so on. So this is what the real line is. So we are representing intervals on the real line right now. So we have represented an open interval. So open interval has these round brackets. It is x such that x lies between a and b. So notice that there is no equal to sign here. So x lies strictly between a and b. Now in the closed interval, x could take on the values a and b. So this open interval is naturally contained within the closed interval. So we have an extra condition, x could take the values a and b. So this you can write like this, say 3, 5. So here x could attain the values 3 and 5. So therefore you will always make a solid circle for a and b. So on the real line, this is how you draw it. Now you have half open intervals. So these two examples are half open intervals. In the first example, b is not contained within the interval, and in the second example, a is not contained within the interval. So let us draw this. So you have a here, and then this b is not contained, so you have a hole for b. And then similarly here you have a hole for a because a is not in the interval whereas b is. So solid for b and hole for a, and then you draw a line between a and b to say this is the interval. So you could write like this, say example is 3, 5, or you could have 3, 5. So again you can see that this 3, 5 is contained within this interval, and this interval. And this closed interval is the biggest because both these are also contained within the closed interval. So again, simple thing is that if there is a round bracket on the left side, that means the left side is not contained in the interval. So for example, you have 3, 5 interval. That means this interval contains everything between 3 and 5, but it does not contain 3. Square bracket means it contains 5. And similarly, if you have something like this, 3, 5. So first you say everything between 3 and 5, but it also contains 3. This interval does not contain 5. Now we talk about power set. So what is a power set? So collection of all subsets of a given set A. So first you fix a set A, and then you talk about all its subsets. So collection of all its subsets is called a power set of A. So you denote it by this curly P of A. So let us take an example. Say A is equal to H comma T. So this example is common in probability. H is say for heads and T is for tail. Then the power set of A is, you have the null set. Obviously empty set is contained within A. So it is collection of all subsets. So we are now talking about all subsets of A. Then you have head. So head is contained in it. Individually tail is contained in it. And then the set H comma T is also contained within A. So obviously A contains itself. So therefore sometimes we write subset with the equal to sign here like this, that A also contains itself. So this is just set A which contains itself. Now if the number of elements in set A is n, then the number of elements in the power set is 2 to the power of n. So this can be proved by a counting argument. So we will not prove this, but this is worth noting. For example, in this example, n is 2. So there are only 2 elements, head and tail. So power set of A contains 2 to the power of 2, that is 4 elements. So now you can count, there are 4 elements. This is 1, this is 2, this is 3, and this is 4. So there are 4 subsets. So each of the subset is an element of the power set. So power set is a collection of subsets of A. Each of this is a subset, and each of the subset is actually an element of the power set. So we have converted subsets to elements of a set, and this big set is the power set. Now we talk about the universal set. So in some cases we have to define like big sets, and these big sets we call universal sets. And these universal sets are needed for particular contexts. For example, you might fix universal set as natural numbers, and then you might want to study subsets of natural numbers within this universal set. For example, you might want to study even numbers, or you might want to study odd numbers, or you might want to study prime numbers. But the big set you have fixed is natural numbers. So let us see an example of this in terms of Venn diagrams. So first we talk about Venn diagrams. So Venn diagrams, they consist of rectangles which have closed curves inside it. So we are going to draw this, and these are used to represent subsets within a universal set. So first you fix a universal set and then you supply subsets to it. For example, say if universal set is natural numbers. So first you draw a rectangle and you say this is the universal set. So this is the universal set. This is equal to say natural numbers. Then we have set A inside it, and set A has elements 2, 3, 5 and 6. So let us draw set A first. So say set A is something like this. So this is a closed curve. So we had consists of rectangles. This is a rectangle and closed curve. So we have drawn a closed curve A. So we are saying it has some elements in it. So it has element 2, it has element say 3, element 5 and element 6. So we have drawn set A. Now set B contains element 5 and 6. So set B is a subset of set A. So we have another set called B inside here. So this is say set B. Then we have set C, which is say consists of element 3, 10 and 11. So you draw set C now. So this is set C, consists of 3, 10 and 11. So this is how a Venn diagram looks like.